Friends, thank you for being here today. What if I told you that a single Canadian plant supervisor working at a lithium processing facility in northern Quebec possesses more power over America's electric vehicle revolution than Elon Musk, the Biden administration, and every American automaker combined? And what if I told you that this individual, whose decisions determine the chemical purity of materials that most Americans have never heard of, can shut down Tesla's Gigafactory, cripple General Motors' electric vehicle production, and destroy America's $174 billion transition to clean transportation with the flip of a single switch? Most people believe that America's electric vehicle revolution depends on American innovation, American manufacturing, and American determination to lead the global transition away from fossil fuels. They assume that Tesla's dominance, Ford's Lightning success, and GM's Ultium platform represent American technological superiority and American industrial independence. They do not recognize what I recognize: the complete subordination of American electric vehicle production to Canadian mineral processing control, executed through refinery operations so critical that Canadian decisions about lithium purity can determine whether American consumers have electric vehicles to purchase. This is not supply chain management. This is the weaponization of chemical processing, placing America's clean energy future at the mercy of foreign technicians who control the refineries that determine whether American automakers can build the electric vehicles that American climate policy depends upon. The American electric vehicle industry represents one of the most ambitious industrial transformations in modern history, with total investments exceeding $174 billion in new manufacturing facilities, battery production plants, and charging infrastructure designed to fundamentally reshape American transportation and energy consumption. President Biden's executive orders mandate that 50% of all new vehicle sales must be electric by 2030, creating regulatory pressure that forces American automakers to rapidly transition their production lines from internal combustion engines to battery-powered electric systems. But this massive industrial transformation depends entirely on access to battery-grade lithium and nickel that meets the extraordinary purity requirements necessary for modern electric vehicle batteries. These materials are not ordinary industrial metals that can be sourced from multiple global suppliers. They are ultra-pure chemical compounds that require sophisticated processing techniques to achieve the 99.5% purity levels that electric vehicle batteries demand for reliable performance and safety. 65% of the battery-grade lithium and nickel used in American electric vehicle production comes from Canadian refineries, specifically from facilities operated by companies like Nemaska Lithium in Quebec and Vale's operations in Sudbury, Ontario. These facilities have invested billions of dollars over decades to develop the specialized chemical processing capabilities necessary to produce battery-grade materials that meet the stringent requirements of electric vehicle manufacturers. The mathematical reality of American dependence on Canadian battery materials becomes apparent when examining the material requirements for individual electric vehicles and the scale of production that American automakers plan to achieve by 2030. Each Tesla Model S requires approximately 63 kilograms of battery-grade lithium and 55 kilograms of processed nickel for its battery pack. These materials must meet purity specifications so demanding that impurities of even hundreds of a percent can cause battery failures, safety hazards, and performance degradation that would make electric vehicles unmarketable. Tesla's Gigafactory in Nevada, which produces batteries for hundreds of thousands of electric vehicles annually, consumes approximately 12,000 tons of battery-grade lithium and 18,000 tons of processed nickel each year during peak production periods. Virtually all of this material flows from Canadian processing facilities through supply chains that have no meaningful alternative sources capable of producing materials at the required scale and purity levels. General Motors has committed $35 billion to electric vehicle development and plans to phase out internal combustion engine production entirely by 2035. The company's Ultium battery platform, which will power all future GM electric vehicles, depends on Canadian lithium and nickel processing for the chemical precursors used in battery cell manufacturing. GM's planned production of 1 million electric vehicles annually by 2025 would require approximately 63,000 tons of battery-grade lithium and 55 000 tons of processed nickel, representing material flows that Canadian refineries must maintain consistently to prevent disruptions in American electric vehicle production. Ford has announced $50 billion in electric vehicle investments through 2026, including massive production increases for the F-150 Lightning electric truck and new electric vehicle models across all product categories. The company's electric vehicle production plans depend entirely on Canadian battery material supplies, as Ford lacks alternative sources for battery-grade lithium and nickel that meet automotive industry quality standards. The individuals who control the production and quality of these critical battery materials are not American government officials or American corporate executives operating under American regulatory oversight. They are Canadian chemical engineers and plant supervisors working for Canadian companies according to Canadian environmental regulations, Canadian safety standards, and Canadian operational procedures that operate independently of American policy priorities or American production schedules. The senior plant supervisor at Nemaska Lithium's processing facility in Quebec possesses the operational authority to adjust production schedules, implement maintenance procedures, modify quality control processes, and respond to regulatory requirements in ways that can immediately affect battery material supplies to American electric vehicle manufacturers. This individual can influence American electric vehicle production more directly than most American government officials or American automotive industry executives. Canadian refinery operations are extraordinarily complex chemical processing systems that require continuous operation to maintain the temperature, pressure, and chemical conditions necessary for producing battery-grade materials. Any interruption in processing operations, whether for routine maintenance, equipment upgrades, regulatory compliance, or safety. Procedures immediately affects the flow of battery materials to American manufacturing facilities that operate on just-in-time delivery schedules. The vulnerability of American electric vehicle production to Canadian refinery operations became apparent during the 2023 maintenance shutdown at Vale's Sudbury nickel processing complex, when planned facility upgrades extended longer than anticipated due to what company officials described as technical complications and regulatory review requirements. The shutdown, which was originally scheduled for 45 days of routine maintenance, ultimately lasted 135 days due to unexpected equipment issues, extended environmental compliance reviews, and additional Indigenous consultation procedures required by Canadian regulatory authorities. The extended shutdown created immediate shortages of processed nickel sulfate and other critical battery precursors that American electric vehicle manufacturers depend on for battery cell production. The timing of the shutdown was particularly problematic because it occurred during the peak production season for American automakers preparing for model year launches and attempting to meet quarterly delivery targets that had been communicated to investors and customers months in advance. Tesla was forced to reduce Gigafactory production by 30% during the extended shutdown, affecting delivery schedules for over 45,000 vehicles across multiple product lines and creating waiting lists that extended delivery times for American customers by 4 to 6 months. The company was forced to implement emergency rationing procedures for available battery materials, prioritizing high-margin Model S and Model X production, while reducing Model 3 and Model Y manufacturing to preserve limited nickel supplies for premium vehicle production. The company estimated that the Canadian refinery shutdown cost Tesla approximately $2.8 billion in lost revenue during the affected period, and an additional $600 million in emergency costs related to sourcing alternative supplies from secondary processors in South Korea and China at premium prices that were 200 and 300% higher than normal Canadian supply costs. Tesla's stock price declined by 23% during the shortage period, as investors recognized the company's complete dependence on Canadian mineral processing operations. General Motors experienced even more severe disruptions because the company's Ultium battery platform requires specific nickel sulfate compounds that are produced almost exclusively at Canadian facilities. GM was forced to halt production at 3 electric vehicle assembly plants for a total of 180 days, affecting approximately 78,000 vehicles and costing the company over $4.2 billion in lost production and contractual penalties to dealers and customers. Ford's F-150 Lightning production was similarly affected, with the company reporting that Canadian nickel shortages forced production delays that affected 34,000 electric truck deliveries and cost Ford approximately $1.9 billion in revenue losses and emergency supply chain costs. The company's stock price declined by 18% during the shortage period as investors recognized the extent of Ford's dependence on Canadian mineral processing. The broader implications of the 2023 Canadian refinery shutdown revealed how completely American electric vehicle production had become dependent on Canadian chemical processing operations and Canadian operational decisions. American automakers found themselves unable to meet production schedules, delivery commitments, and sales targets because of maintenance decisions made at Canadian facilities by Canadian engineers operating according to Canadian priorities and Canadian timelines. The psychological impact on American automotive industry leadership was profound and demonstrated how rapidly the assumption of American industrial independence had become obsolete in the electric vehicle era. Executives who had built careers around American automotive dominance found themselves managing production systems that could be disrupted by foreign maintenance schedules and foreign regulatory procedures beyond American control or influence. Board meetings at major American automakers began including detailed discussions of Canadian environmental regulations, Canadian labor relations, Canadian political developments, and Canadian industrial policies that could affect American electric vehicle production. Automotive executives found themselves monitoring Canadian provincial elections, Canadian environmental reviews, and Canadian Indigenous consultation processes as closely as they monitored American consumer demand and American regulatory requirements. Tesla, General Motors, and Ford established dedicated liaison offices in Toronto, Montreal, and other Canadian cities, specifically to maintain relationships with Canadian refinery operators and monitor Canadian operational developments that could affect American electric vehicle production. American automotive companies found themselves operating as supplicants to Canadian chemical processing facilities, seeking to maintain favorable relationships and priority treatment in supply allocation decisions. The Biden administration's ambitious targets for electric vehicle market penetration depend entirely on Canadian cooperation in maintaining battery material supplies that American companies cannot source from alternative suppliers. American climate policy and American energy security have become subordinated to Canadian industrial capacity and Canadian policy decisions about mineral processing operations. The success or failure of American efforts to reduce greenhouse gas emissions and achieve energy independence now depends more on Canadian refinery operations than on American technological innovation or American manufacturing investments. The Department of Energy has conducted classified assessments of American vulnerability to Canadian battery material supply disruptions, recognizing that Canadian decisions about refinery operations could undermine American climate policy objectives and American automotive industry competitiveness. These assessments reportedly conclude that extended Canadian supply disruptions could force delays in American electric vehicle adoption that would compromise American ability to meet international climate commitments and domestic emissions reduction targets. American environmental groups and climate policy advocates have discovered that their objectives depend as much on Canadian industrial cooperation as on American political will and American consumer acceptance of electric vehicles. Traditional American approaches to environmental policy that assumed American control over the industrial systems needed to achieve environmental objectives have been complicated by dependencies on Canadian processing facilities that operate according to Canadian environmental standards and Canadian regulatory priorities. The technological sophistication required for battery-grade material processing creates additional vulnerabilities because the chemical requirements for electric vehicle batteries are so precise that alternative suppliers cannot quickly replace Canadian refinery capacity without extensive facility development, process optimization, and quality certification procedures that could take years to complete and cost billions of dollars to implement. Battery-grade lithium requires processing techniques that remove impurities to levels of less than 0.1% while maintaining specific crystal structures and particle sizes that affect battery performance characteristics, including energy density, charging speed, and operational lifespan. Canadian refineries have developed proprietary chemical processes and quality control systems that enable them to consistently produce materials meeting these demanding specifications. The development of alternative battery material suppliers would require not only massive capital investments in processing facilities, but also extensive research and development programs to replicate the specialized chemical processes that Canadian companies have optimized over decades of production experience. American companies or American government agencies seeking to establish domestic battery material processing capacity would face technical challenges that extend far beyond simple facility construction to encompass complex chemistry, specialized equipment, and accumulated operational expertise. Canadian refinery operators possess detailed knowledge of the specific processing conditions, chemical treatments, and quality control procedures necessary to produce battery materials that meet automotive industry requirements. This technical knowledge represents years of accumulated experience and proprietary process development that cannot be quickly transferred to alternative suppliers or replicated through reverse engineering of Canadian production methods. The legal and regulatory framework governing Canadian mineral processing operations provides Canadian companies with substantial discretion to modify production schedules, implement maintenance procedures, and adjust quality standards according to Canadian environmental regulations and Canadian operational priorities. Canadian processing facilities are not required to prioritize American electric vehicle production schedules or accommodate American automotive industry requirements when making operational decisions that affect battery material supplies. Canadian environmental regulations and Indigenous consultation requirements can affect refinery operations in ways that create immediate disruptions in battery material supplies to American manufacturers. Processing facilities that operate in areas subject to Indigenous land rights or environmental protection requirements must obtain various permits and approvals that can be delayed or modified according to Canadian legal processes and Canadian political considerations. The contractual relationships between Canadian battery material producers and American automotive companies are governed by Canadian commercial law and Canadian regulatory procedures that give Canadian suppliers substantial flexibility to adjust delivery schedules, modify quality specifications, and implement operational changes that could affect American electric vehicle production. American automotive companies have limited recourse when Canadian operational decisions create material shortages or cost increases, The strategic effectiveness of Canadian battery material leverage was demonstrated during recent trade negotiations when Canadian officials suggested that American policies affecting Canadian mining interests could influence Canadian companies' ability to maintain efficient processing operations. American negotiators found themselves considering the electric vehicle implications when evaluating trade policies that might conflict with Canadian industrial interests. The broader implications extend to fundamental questions about American ability to achieve strategic autonomy while remaining dependent on foreign suppliers for critical processing capabilities. The electric vehicle industry, which was supposed to reduce American energy dependence, has instead created new forms of foreign dependence that may be more constraining than traditional oil imports because they involve specialized processing rather than commodity materials. The integration of Canadian battery material processing into American electric vehicle production has created technological dependencies that operate continuously rather than only during specific crisis periods. Every Tesla, every GM Ultium vehicle, and every Ford Lightning that rolls off American production lines contains battery materials that were processed at Canadian refineries by Canadian workers, according to Canadian quality standards and Canadian operational procedures. The mathematical precision of this dependency cannot be disputed through policy rhetoric or alternative procurement strategies. American electric vehicle production requires Canadian battery materials. Canadian battery materials require Canadian chemical processing. Canadian chemical processing operates according to Canadian priorities and Canadian operational schedules. The numbers are clear, and they reveal the complete subordination of American electric vehicle production to Canadian mineral processing control. The transformation of battery material processing from industrial service into instrument of international leverage represents one of the most sophisticated but least recognized shifts in modern strategic relationships that will define the next decade of global competition. The Canadian plant supervisor who controls lithium and nickel processing operations possesses more immediate power over American electric vehicle production than most American automotive industry executives or American energy policy officials. Canadian officials have demonstrated that modern electric vehicle production is so dependent on specialized chemical processing and precise material quality that controlling battery material refineries provides more effective leverage over automotive industries than traditional forms of economic or diplomatic pressure. The chemical processes that create battery materials have become more powerful than the vehicles they enable, because without Canadian processing capabilities, American electric vehicles simply cannot be manufactured. The age of American automotive independence has been replaced by Canadian chemical dependency that operates through technical systems most Americans never see or understand. American electric vehicles may carry American brand names and serve American environmental objectives, but they depend entirely on Canadian permission to exist. Tesla's Gigafactory, America's symbol of electric vehicle innovation and manufacturing prowess, can be shut down not by competition or technological failure, but by a Canadian plant supervisor who decides that lithium processing equipment requires additional maintenance. General Motors' $35 billion electric vehicle investment can be rendered worthless by Canadian decisions about nickel refinery operations that prioritize Canadian environmental compliance over American production schedules. The Biden administration's ambitious climate targets and electric vehicle mandates depend more on Canadian cooperation than on American policy implementation or American consumer acceptance. America's transition to clean transportation operates only with Canadian permission, using Canadian materials processed by Canadian workers, according to Canadian standards and Canadian priorities. This is how technological revolutions create new dependencies that reshape global power structures. The materials that make electric vehicles possible are controlled by foreign companies operating according to foreign priorities and foreign operational procedures that can change without warning. The chemical processes that enable clean transportation have become the choke points that determine American environmental policy success. Most Americans believe their electric vehicle future depends on American innovation and American manufacturing capacity. But American electric vehicle production depends entirely on Canadian chemical processing facilities that can be shut down by Canadian maintenance schedules, Canadian environmental regulations, and Canadian operational priorities. The Tesla killer is not located in Detroit or Silicon Valley. It is located in Canadian refineries where chemical engineers decide whether American electric vehicles can exist. The Canadian refinery supervisor may never choose to exercise this power deliberately, but the mere fact that it exists fundamentally alters American automotive planning and American energy policy implementation in ways most officials refuse to acknowledge. America builds its electric vehicle future only with Canadian permission, using Canadian materials processed according to Canadian standards by Canadian workers who answer to Canadian management and Canadian regulatory authorities. This is how clean energy dependencies create strategic vulnerabilities. The revolution that was supposed to provide American energy independence has created new forms of foreign dependence that are more direct and more immediate than traditional oil imports. The electric vehicle that represents American technological progress can be eliminated by Canadian decisions about chemical processing priorities and refinery maintenance schedules. If this revelation about Canada's stranglehold on America's electric future shocked you, you need to see what's coming next. The hidden dependencies I've uncovered go deeper than anyone imagines, and they're accelerating. Hit that subscribe button and turn on notifications, because the next video will expose a Canadian leverage point so critical that when you understand it, you'll realize America's entire technological supremacy hangs by a thread controlled by our northern neighbor. The future belongs to those who see these patterns first. Don't be left behind when the next domino falls.